Hello students, in this video I'm going to cover the last question of your EOT, that is the question number 19. So as per your question number 19, you should understand the different type of forces and the free body diagram. So for this I'm going to explain you some basics and then I will start the question. So concept of force, you need to understand, there are lots of forces on the body. Let's say there is any body, okay, and when it is a stable body there are the four forces. One downward, one is upward. You will always get these forces. So this is called Fg, which is equals to weight, which is equals to mg. Always remember, you will get this force. Up force is called normal force, N. One is called applied force, applied force, and this side you will get force of friction, force of friction. Okay, a easy technique for you to solve the question: just balance x-axis and y-axis. So whatever you have in the x, let's say, can I say N is equals to mg and force of applied is equals to force of friction. Like this you can balance the things. Okay, this is the case 1. Case 2, rope case. Rope, wire, string, all these type of forces. Okay, so let's say if you have a word like this is the I need to take the another one. There is a body and you have a rope which is taking this. So this is the wire. So you need to break the angles here. A simple angle. Let's say this is the theta. This is the word called tension. This is also a force, but the name is different, tension. Okay, so you will get 2. See, this is Fx, which is equals to tension cosine theta, and here you will get Fy, which is equals to tension sine of theta. Is it clear? Okay, third thing which you need to focus: friction. What is the friction? Friction, we know the opposing force, and there is a formula called mu times of n. Mu times of n in any body. Let's say this is the body. Here is the n is the normal. This is the friction F, which is always equals to mu times of n. Here is your mg and here is your force applied. Clear? These are the basics. Okay, fourth one. Let's say if you are moving along any let's say not on the straight path. This is the situation and this is the body. Okay, so the body is trying to go down and force of friction is up. In this case, the major point, where is the normal? Normal force is always perpendicular to the surface. You understand? Here is your N and here is your mg. So you need to break down this into two parts. One is like this. Here is angle theta. So it will becomes your mg cosine theta. And this axis will gives you mg sine of theta. Do you understand? Sure. Okay. So then how you will balance the thing? So you can balance x-axis and y-axis. So on x-axis, this is your x-axis. So how will you balance? Force of friction is equals to mg sine of theta. And the second thing you can say n is equals to mg cosine theta. Clear? Like this you can balance, and you need to check which is the greater value. That I will cover in the question. Okay, that is called net force, or I will just tell you the word called net force from the beginning so that you can relate that. Let's say your applied force is more, the body is going this side. So can I say FA, applied force, is greater than force of friction? So where the body is going, going towards right. So I can say force, applied force minus F of F is equals to net force, F net. And what is F net? Always remember, F net is M times acceleration. M times acceleration. This is the simplest thing. You need to just focus, and like this you need to solve your questions. Okay. So now we are going to start with question number 1. So let's see. Question number 1. A gymnast of mass, okay, mass is given, hangs vertically from a pair of parallel rings. Okay. So we have the two cases, case number B and case number C. If the ropes supporting the rings are vertical and attached to the ceiling directly above, what is the tension in each rope? Okay, the first point what we need to understand, as per the diagram 1, first you should know how to make the free body diagram. It is already given in the question. One force you can see, tension is going up, second tension is going up, and third thing you can see Fg, which is equals to Mg, which is going down. How many forces are going up? 2. So can I say T plus T is equals to Mg? T plus T is equals to Mg. So 2 times of T is equals to Mg. So T is equals to Mg divided by 2. Solve the values. So what is the value? 55 is the mass. Gravity is 9.81 divided by 2. You get 27 0 Newton. 270 Newton. Is it fine? Okay. Because the body is balanced here. Body is balanced. So if body is balanced, if body balanced, in that case F net is always 0. F net is 0. Okay, now solve the case number 2. You can see in the case number 2, we have one tension is like this. Okay, I will draw it here for you. One tension is like this. So you can solve two parts, one along x-axis, one along y-axis. So you will get t cosine theta, you will get here t sine of theta. Yes or no? Okay. Similarly, second one like this. So just take the another color. Okay, so here is your t. So here is the angle theta. So t cosine theta, t sine theta. So cos and cos can cancel out each other. So we will get 2 times of t sine theta. Okay, now just solve, like this. Now it will become easier for you. T. So here you will get t cosine, t sine theta. Okay, t sine of theta, t sine of theta. Here you get t cosine theta, here you will get t cosine theta, and downward you have mg. So can I say x-axis? X-axis. T cosine theta is equals to t cosine theta. So the net result is 0. Net result is, because if you transfer this side, it will become 0. Okay, y-axis. Y-axis. So how many forces? T sine theta plus t sine theta is equals to mg, because body is balanced. If the body is balanced, F net, which is equals to ma, which is equals to 0. Okay, now, so can I say 2t sine of theta is equals to mg. What we are looking for? Tension. So mg divided by 2 sine of theta. Place the values and get the answer. Fine. Okay. Next, this is something very good one. This one is important and good one. How does the tension in the rope change as the angle between the ceiling and ropes becomes smaller. Okay, we know the tension. T is equals to mg over 2 sine theta. We know from the graph, this is the graph of sine. Here is the angle 90 degree. Here is the angle 0. So if the theta is getting less, then what will happen? Then sine of theta is approximate equals to 0. So T is equals to mg divided by 0, which gives you infinite. It means when angle is reducing, when theta reduce, tension increase. Clear? Understand? Okay, next question. A tow truck of mass M is using a cable to pull a shipping container of mass M, okay, mass M, across horizontal surface. The cable is attached, okay, truck of mass capital M, and shipping container, okay, fine. So the cable is attached to the cable, means wire we have in the question, okay, is attached to the container at the front bottom corner, makes an angle theta with the vertical. Okay, this is something very important, huh? Where is the angle? You need to understand. Let's say this is the vector. If the angle is with the x-axis, it means with horizontal. This point you need to focus during the exam. And if the angle is here with the y-axis, this is called with vertical. With the vertical. Clear? Okay. Coefficient of kinetic friction. Okay. We are looking for friction. Easy question, huh? And very interesting question. First, draw the free body diagram. Take the body. Let's say this is the body. Easy to make the free body diagram. First point mg and the upper point is n. Till here clear? Okay. Make the line like this. Where the force is going, tension is going. Okay. This is your tension. And where is the angle theta? Here is your angle theta. This is T. So can I say this is your T cosine theta. And here is your T sine of theta. We solve T as T cos theta and T sine theta. Okay, what will be here? Force of friction. Force of friction. I told you what is force of friction? Mu times of N. Okay, now just balance the x-axis and the y-axis. Can I say x-axis? T sine theta is equals to force of friction, which is equals to mu times of N. Yes or no? Okay, because the major word you need to understand here, the container is with the constant speed. Constant speed means V capital constant. Acceleration is equals to 0. So F net is also equals to 0. So no need to use it. So you can directly use this. So T sine theta is equals to mu times of N. So what is the value of N here? N is equals to T sine theta divided by mu. Clear? Okay, now the vertically. So vertically what you can say, okay, I will write vertically here and now solve it. So N is equals to, okay, what we have, N plus, we have the two factors, N plus T cosine theta is equals to mg. Clear? Okay, put the value of N here. N we already signed. So T sine theta divided by mu plus T cosine theta is equals to mg. Fine. Okay, multiply with mu all the sides. So what you will get, T sine theta plus mu times of T cos theta is equals to mu times of mg. Okay, so take T common from here, T and T common, and take all the things other side. So you will get T is equals to mg, or this one, this is the better one, so you will get direct result. So T is equals to mu times of mg divided by sine theta plus mu k cosine theta. Clear? So this is your two things. First is the free body diagram and second is your finding the tension. Okay, next question. A block of mass, okay, mass is given, M is here, 20 kg, okay, supported by a vertical massless, okay, there is no mass cable initially at rest, so initially rest means V velocity, initial velocity is 0. The block is then pulled upwards. Okay, now you have the net force because the acceleration is given. F net. Now guys, you need to focus upon F net, which is equals to MA. As per the question, what do you understand? This is a body, okay? There is a wire and we are applying a force and the body is going up. Body is going up. So how many factors we have? We have the word called tension here. Downward we have mg. So can I say in a simple way, tension is greater than mg? First statement. Do you understand? Okay. If it is greater, T minus mg should be equals to your F net. Yes or no? Because net force means the difference of these two. Okay, now just solve it. So can I say step number 2? Now step number 3, T is equals to, what is F net? F net is M times A. MA plus MG. So take out M common, A plus G. Clear? Now solve it. Just place the value. You have M. Okay, what is the value of M? 20 bracket. A is 2.32 plus 9.81. Once you solve it, you will get 243 Newton. So whose value? Tension's value. Okay, first question solved. Second, what is the net force? Net force means F equal to MA. Mass is 20. Acceleration is 2.32. So what is the value? Solve it. 46.4 Newton. Fine. What is the speed? Okay, that is something interesting. And what is the speed of the block after it has traveled 2 meter? Distance is also given. So we know Vy square. Okay, final velocity and initial velocity. So I will explain it here so that it will become easier for you to understand. We know V final square is equals to V initial square plus 2AX or 2AY. So V final we are looking for, okay, V final square. Initial is 0, already at rest, plus 2, A is 2.32 and the distance is given 2. Solve it. So VF is equals to 3.05 meter per second. Clear? Okay. Next question. This is, okay, second last question and the interesting one. You need to understand just the diagram and the question will be finished. Even if you see the diagram, all the things are clear. Let's say, simple thing. This is the body. We have the 4 forces, okay? N, mg. Till here clear? And here is force of friction. 3 forces are clear. For 4th force, there is a word called tension. And the theta is with the x-axis. So can I say T cosine theta? And here is T sine of theta. Yes or no? Now you can solve. Just you have the x-axis, you have the y-axis. So can I say x-axis, x-axis, or you can say the horizontal. Can I say force of friction is equals to T cosine theta? Yes or no? Yes or no? You can solve this. But we have to check whether it is moving or not moving. So we cannot directly place this. So we have to check whether it is the net force is 0 or not 0. Clear? Now read the question. You understand the free body diagram? Okay. A tractor pulls. Okay. Now you have free body diagram with F net. This is called F net, which is equals to M times A. A sled of mass, okay, mass is given across a level ground. The coefficient of kinetic friction between the sled and ground is, okay, mu is given. The tractor pulls means he said there is a F net. The sled by a rope tension that connects to the sled at an angle. Okay, angle is given above the horizontal. Angle is with horizontal. You can understand from here. Angle is with horizontal. What is the magnitude of tension of the rope necessary to move the sledge? Okay, acceleration is given. Okay, now try to understand the x-axis. X-axis. Now you will understand. You have two factors, friction and T cos theta. So can I say T cosine theta is greater than mg? T cosine theta is greater than force of friction. So can I say T cosine theta minus force of friction, which is equals to F net? Yes or no? So if I can remove the F net, can I say M times A? Yes or no? So force of friction, we know that is mu times of N. So T cosine theta minus mu times of N, which is equals to MA. This is your equation number 1. So you can find the value of N. So this is your N. Clear? First term clear. So after this one directly. Okay, now solve the vertical also. In the vertical, we have two forces, N and T sine theta. Second is mg. And body is not going up. So there is no net force. So can I say vertically, a very simple thing, N plus T sine theta is equals to mg. F net is equals to 0. Why? Because there is no acceleration in the y-axis. Fine. So we find the value of N here. Okay, place the value of N here and solve it. Okay, so you get this equation, T sine theta plus N minus mg. You take this side. So you get T sine theta plus N, value of N from here. T cos theta minus mg divided by mu. Minus mg equals to 0. You get tension is equals to, this is the formula. Solve it and you will get the solution. Understand? Okay, might be some of the student will not understand, so I will explain this part step by step. Okay, I will take a page here. Just give me a second so that I will explain this. Hold on. Okay, now I will explain this. So we have N is equals to T cos theta. N is equals to T cosine theta minus MA divided by mu. Okay, this is for the horizontal. Now for vertical axis. For the vertical axis, we know T sine of theta plus N, which is equals to mg. F net is equals to 0. Why? Acceleration along y-axis is 0. So can I place the value of N here? So I can say T sine of theta plus value of N, T cosine theta minus MA divided by mu, which is equals to mg. Multiply both side with mu. So you will get mu times of T sine theta plus T cosine theta minus MA, which is equals to mu times of mg. So what we are looking for, we need to check this thing, that we are looking for tension. So how to solve the tension? Take these things, one value and two value. So, and this value this side. So take out T common, mu sine of theta plus cosine theta bracket is equals to mu times of mg plus ma. Clear? Okay. Now just place the value. So T is equals to divide by mu sine theta plus cos of theta, both side. Okay, so now what will happen? T equals, take m common, m mu times of g plus a divide by mu sine theta plus cosine theta. Clear? Now place the values. All the values are given. So mu, okay, mass, mu, everything is given. So what is the value? Value of mu is 0.6. Mass is equals to, the value of your mass is 1000 kg. G we know 9.81. Acceleration is your 2. Okay, and theta is your 30 degree. So once you solve it, T is equals to, so you just put 1000 bracket, mu is your 0.6 times 9.81 plus 2 bracket, mu is your 0.6 0.6 sine 30 degree plus cosine 30 degree. You solve it, you will get T is equals to 6760 Newton. Clear? Okay. Now we are on the last question, and the question is, a block of mass, okay, mass is given, is sliding at constant velocity. Okay, this makes lots of things. Constant velocity, v is constant, acceleration is dv by dt, which is equals to 0, f net, which is equals to m times a, acceleration is 0, so f net is 0. Okay, down an inclined plane makes an angle, okay, 37 degree with respect to the horizontal. This is something very important. Let's say this is the inclined plane and there is the body, here is the angle, this is your mg, okay, and here is the n normal. Till here clear? Things are clear? Okay. Now what you need to observe, when you break these two vectors, 1 and 2. So here is the angle. This is the theta, because he said with the horizontal. Because this is called horizontal and you are shifting towards up. So this line is the horizontal. Fine? Okay. So here is your mg cosine theta and here is your mg sine of theta. Here is your frictional force. Fine? Do you understand? So now it becomes very, very easy. There is no net force. Okay, so balance the x-axis and balance the y-axis. If you balance the x-axis, can I say mg sine theta, mg sine theta is balanced with frictional force ff? Yes or no? Okay, so can I say mg sine of theta, frictional force is ff, or you can say mu times of n. Clear? Okay. Second, you can solve the y-axis also. So n is equals to mg cosine theta. So just solve them individually and question is your finished. What we are looking for? Frictional force. Okay, solve first part. For the frictional force, we can say mg sine theta, mg sine of theta is equals to frictional force. Solve this. So we have the value, m is 5, g is 9.81 and sine of angle is given 37 degree, which is the frictional force. So what is the value? Frictional force is equals to 29.5 Newton. This is the part number 1. Okay, before going to solve this part number 2, you should know frictional force is equals to mu times of n, which is equals to 29.5 Newton. Okay, in case number 2, coefficient of kinetic friction. Okay, so what we are looking for? We have to find out mu. Okay, so use the second equation. N is equals to mg cosine theta. So what is the value of m? Okay, 5 times 9.81 times cos of 37 degree. So the value is 39.2 Newton. So guys, what we have, okay, solve it here so that it will become easy for you. You have 29.5 force of friction is equals to mu, n is 39.2. Divide by 39.2, so mu is equals to 0.75, and there is no unit for this. Clear? So from here, your question number 19 is finished and you are ready with all the questions of your writing part. So from my side, for your writing part, all the very best, and do your exams in a proper way. Okay, all the best guys.